Hello everyone, welcome back to the channel. Today I'm going to conduct a experiment to prove the truth table of a NOT gate. There will be two experiments where I'll be using a simulator known as Circuit.js to prove the truth table. So in the first experiment, I'll be using a inbuilt NOT gate, and in the second experiment, I'll be making a NOT gate from a transistor. In both the experiment, the main aim is to prove the NOT gate truth table. So without further ado, let's get into it. So guys, my simulator is already running, so I'll just go and create a new blank circuit. And before we start with the experiment, let's just make a truth table first of all. And once we have done with the truth table, we can start on with the experiments. So this will be input, this will be output, this will be case 1, this will be case 2, this. So in case 1, if we give 0, we get an output of 1. In case 2, if we give an input of 1, we get an output of 0. So let me align everything properly and make this a little bit bigger. Okay, so as you can already see, we have a truth table over here. In case 1, if we give an input as 0, we get an output as 1. In case 2, if we give an input as 1, we get an output as 0. So let's start with experiment 1. In experiment 1, I'll be using a built-in NOT logic gate or inverter logic gate, you can say. And I will be needing a logic input and a logic output to display the input and output, right? Okay, so as you can see, we have already proven the case 1. Case 1 is if we give an input as 0, we get an output as 1, right? In case 2, if we give an input as 1, we get an output as 0. So we have already proven the truth table using the built-in logic gate of the simulator. Now we will be making a logic gate, the same NOT logic gate, using a transistor. For that, let's first put exp2. Now for this experiment, I will be needing resistors and transistor, okay, and a power supply input and output. Same as you can see in this one, we already needed an input and we needed an output to display, but in this one it is more technical. Okay, so I have referred a schematic on the internet. I'll be giving the link for that schematic in the description box below. If you want to refer that schematic, you are very welcome to go to that website and have a look onto it. So we will be needing a NPN transistor. Okay, I'll be needing a resistor at the collector of the transistor and at the base of this transistor. Let's connect the wires and I'll be getting the output for this logic gate from the collector. And let me connect the ground, let me connect the logic output, and let me connect the logic input. Okay, let me edit first of all to numeric, and let's give a input of 5 volts. Okay, as you can already see, we have already proven our first case like previously. So once we give the input as 0, we get an output as 1, and if we give an input as 1, we get an output as 0, as you can see. Hence we have proven the truth table of the NOT gate. So this is the basic representation of the NOT logic gate when we make a schematic. Okay, and we also have specific ICs containing multiple of this NOT gate into it. And when you make a NOT logic gate from transistor, this is how it looks like. Basically all the logic gates are made out of transistor, but to represent it in a simpler way, we use this symbol. So we have proven the truth table for the NOT logic gate. This is pretty much it for this experiment, guys. I hope you guys understood the procedure for this experiment to prove the truth table of the NOT logic gate. If you have any question regarding anything, you can drop a comment in the comment section down below. Make sure to subscribe to this channel and turn on the notification bell so you can get the notification for the upcoming experimental videos. So guys, see you in the next one.